All right, 3.6.28, here we go. Same as the last problem. Find all the zeros. And again, for me, you can use the rational root term if you want, where you take all the factors of that last term, divided by all the factors of the leading term, divide them out by hand until you find the ones that give you remainders of 0. But I'm going to resort to something more like the Desmos program or graphing calculator to put this in. And since I don't have a way to demonstrate the graphing calculator so you can see it on the recording, I will show you how to use Desmos to do this. So you would, first of all, make sure you have your equation, right? Negative 3x to the 5th minus x to the 4th minus 6x cubed minus 26x squared minus 23x minus 5. And then jump over to something like Desmos and accurately, hopefully, type it in. If it goes the way my other problems have gone today, it's probably not going to get typed in right. Mistakes happen. Negative 3x to the 5th minus x to the 4th minus 6x to the 3rd minus 26x squared minus 23x and minus a 5 give us the solutions. Now, it looks like there's 3 zeros right here. So since we had a degree 5 problem, you should have 5 zeros. We have 1 at negative 1. Well, that's a double though, right? Because it bounces off. So we have negative 1, which is multiplicity 2. And then we have 1 over here that's at this negative 1/3. So then here's what we would have to do to find the other 2. That's 3 of them, but we need 5 to go with this degree. And I don't think, if we zoomed out, I don't think it looks like it's definitely the ends are going to infinity. So we don't have any other real ones. We'll have to find what the other ones are. They must be complex or imaginary. So we'll divide these 3 that we know out. All right, so let's divide those 3 out of here. Synthetic, if you will. Long, if you would rather, but I'm going to use synthetic. I had the negative 1s. Let's see if I can do this without a mistake this time. Negative 3, negative 1, negative 6, all my coefficients from my original polynomial. Negative 26, negative 23, negative 5. First term comes straight down. And negative 3, multiply positive 3, add straight down. Negative 1 times 2, multiply negative 2, add straight down. Negative 1 times negative 8, positive 8, add straight down. Negative 1, remember, if I've done it right, I got to get a remainder of 0. Negative 1 times negative 18, positive 18, add straight down. Negative 1 times negative 5, positive 5. Okay, so that's how you can kind of know if you made a little bit of a mistake there at all. We did get a remainder of 0, and since that was one of our zeros, it better work that way. Take a negative 1 out again, because remember it was a double root. First one comes straight down. Negative 1 times negative 3, 3. Add straight down, 5. Negative 1 times 5, negative 5. Add straight down. Again, we better get a 0 for a remainder if we've done everything right. Negative 1 times negative 13, 13. Add straight down. Negative 1 times negative 5, 5. Add straight down. Okay, so then what was the last? We had the last 0 that was a negative 1/3. So remember, when you solve that, if you wanted the factor, you can't have fractions when you write this. When you're doing a factor, you make it equal 0 and all of that business. So how would we undo this? I'd start by multiplying by a 3. That cancels out that denominator. So I'm just trying to get it so it equals a 0 here without any fractions. And then I would add that 1 to the other side. So if I have a 0 at negative 1/3, the factor is this 3x plus 1. So just a reminder of that. So now if I take out the negative 1/3 out here though, again, I better get a 0 for my remainder when I'm done. But also if you remember, I explained this in another video where our answer, because it's really not a negative 1/3 here, it's really supposed to be a 3. And since we're dividing by 3, our answer down here is going to be 3 times bigger than it's supposed to be. So we'll see, we got to divide all of the numbers by 3 to solve that. So bring down this negative 3. Negative 1/3 times negative 3 would be positive 1. Add straight down. Negative 1/3 times 6 would be negative 2. Add straight down. Negative 15. Negative 1/3 times negative 15 is positive 5. Add straight down. Again, since this was supposed to be a 3x, we're doing 1/3. These are all 3 times bigger than they're supposed to be. So what we really have, we have to divide all these by this denominator. So we were going to have a negative 1, a 2, and a negative 5. So this is numbers, x's, x squareds. That would be what's left after we take those 3 out. But then what are the zeros created from this? Negative x squared plus 2x minus 5. Well, if you want the other 2, we could do a little quadratic formula to show that works too. X equals negative b plus or minus the square root of b squared, which is the 2 squared, minus 4ac. 4 minus times minus would be a plus, times that would be another minus. 4 times this 5 would be a 20, all over 2a. 2 times negative 1, negative 2. So if I simplify this, it's negative 2 plus or minus square root of negative 16 all over 2. Running out of space. I'm going to bring this up here to the top to finish it for the other zeros. So that'd be negative 2. Square root of 16 is 4. But since it was a square root of a negative, there's an I. And then it's all over 2, or each of these over 2 is another way to write it instead. So negative 1 plus 4 divided by 2 would be 2i, or negative 1 minus 2i. So then we have 1, 2, 3, 4, 5 of our zeros. And it says repeat them if there were multiple again. Repeat any if they're multiple. So on this one, negative 1, because it was a double root, multiplicity 2, negative 1/3, and then negative 1 minus 2i, and negative 1 plus 2i for all of my zeros for that problem, 3.6.28.